Hey guys, welcome back. When Hadoop was still new around 2008, New York Times worked on a project named Time Machine. Time Machine is a collection of full-page image scans of newspaper articles from 1851 to 1922. And this is, as you can imagine, terabytes of data. In this project, New York Times used Hadoop and ingested about 405,000 very large TIFF images and about 3.3 million articles and converted them to web-friendly, efficient 810 PNG images in less than 36 hours. The project we are going to see in this lesson is inspired by the Time Machine project. We're not going to use New York Times articles as input files since we don't have them. But we are going to use the Hadoop source code Java files as input and convert these files into PDF files by writing a MapReduce program and executing the same in Hadoop. As you can see, these are our input files, the source code files from the Hadoop project, and you can open the file in Notepad. There you go, that's our input. I have already uploaded all these files into HDFS. And our plan is to write a MapReduce program to convert all these files into PDF. Sounds like a plan? Perfect. Now we have the input files that we're going to convert ready. Let's think about how we can represent this problem in MapReduce. What do you think? How we can solve this problem using MapReduce? Let's talk about the reduce phase first. Do we have anything to aggregate in this problem? We have to pick up a file as a whole and convert it into a PDF. As a whole, there is nothing to aggregate here, correct? So all we need here is a mapper. So we are not going to write a reducer for this job. Now, let's talk about the input format and output format that we will use in our program. Let's talk output format first. The output of our MapReduce program should be a PDF file. Can we use text output format as the output format in our MapReduce job? No, we cannot, because text output format is designed to write text files, whereas here we want to write PDF files. So we have to come up with our own output format and we'll call it PDF output format. What about input format? Same question again. Can we use text input format as our input format? To answer that question, we should understand the purpose and functionality of input format. The purpose of the input format is to 1. Read the file, and 2. For each record in the file, create key value pair, and then finally call the mapper once for each record in the file. Reading the file is easy. Even though the input files we're going to process have .java extension, they are basically text files. Now for each record in the file, we need to create a key value pair. In our specific text to PDF conversion project, what is a record for us in a file? If we use text input format, for instance, a record would be a line in the file. Whereas in our case, we have to pick up the file and convert the whole file into a PDF. So a record in our case will be the whole file. Next, what should be our key value pair? We will use the file name of the input file we are processing as the key, and we will represent that as a text. The value should be the file represented as a PDF object. We don't have an out-of-the-box PDF writable object in Hadoop. So we'll create PDF writable to represent a PDF object and we'll use that for the value in the key value pair. So we will create a new input format named PDF input format, which will read the file as a whole and call the mapper with file name represented as text and the file contents as PDF writable for the value. Now let's look at the whole picture. We will use PDF input format to read the input files. The mapper will be called with PDF writable object, which is the contents of the file represented in PDF format. The PDF writable object will be then passed to PDF output format, which will write PDF files as output into HDFS. The important reason why we chose to use this project in our course is to show you how to write custom input format, output format, and writable objects. We will see PDF input format, PDF writable, and PDF output format one by one. Let's start with PDF input format. The PDF input format will extend file input format. Let's say we have an input file that we want to convert to a PDF file, which is 200 MB in size, and our block size in the cluster is 128 MB. Do you think we should split the file during processing? That is, Do you think a 200 MB file should be split into two splits with 128 MB as the first split and the second split with the remaining 72 MB? And each split should be processed by two separate mappers? If we do that, we would end up with two PDF files, and that is not ideal. So we should process each file as a whole. That is why the very first thing we will do is override isSplittable method and return false. This means the input file will not be split. Every input format implementation should implement a record reader implementation. Record reader is responsible to return key value pairs for each record. In our case, we need to process the file as a whole and get the file name for key and PDF writable object for value. So we will create a new record reader implementation and name it PDF record reader by extending the record reader. Next, we'll get access to the split we are processing in the initialize method. Remember, we are not splitting the files. So the split here represents the whole file. The next key value method is where most of the work happens. In this method, we'll assign key and value. We need to get the entire contents of the file as value. Using the file system object, we'll open the split and get the input stream for the split. Then we'll read the contents of the split as a whole and write the contents into a byte array. We will then initialize a PDF writable object using the byte array. This will be the value in our key value pair. For the key, we'll simply get the file name from the split, and that is it. Our key value pair is ready. The current key and the current value method simply returns the key value respectively. Now that is it. Our PDF input format is ready. So now let's move on to look at PDF writable. The main function of any writable object is to serialize an object in a simple and efficient manner so that the serialized object can be used in transmission between nodes. The PDF writable we have is very simple. We will first implement the writable interface. We then have to implement two methods. One method to write the PDF content to the stream, and it's called the write method, and another method to read the PDF contents from the stream, named read fields. Let's look at the write method first. In the write method, we'll take the bytes that we read from the split and create a PDF document. We are using iText library to create the PDF document here. It is very simple to use. Create a PDF writer instance, open the document, and using the bytes that we read from the split, create a paragraph and add the paragraph to the document and close the document. The main function of the write method is to write the contents of the object into the stream. Now that we have the PDF document, which is our content, we use out.write method to write the document to the stream. The read fields method, however, does the opposite. It reads what we wrote in the write method. In this method, we read the bytes from the stream and we initialize the PDF reader. The PDF reader that we initialize here will be used in the PDF output format. Let's look at the mapper now. The mapper we have is very simple. We'll get the file name as key and the PDF writable as value. And we simply emit the same as output for key value pairs with no modifications to it. That is it. Our mapper is ready because we have already taken the input Java file and converted that to a PDF document in the PDF writable's write method. So all the mapper has to do is to just simply emit the key value pair. Moving on, let's look at the PDF output format. Just like we implemented a record reader implementation in the PDF input format, we'll implement a record writer implementation in the PDF output format, and we'll call it PDF record writer. The write method in the PDF record writer will get the key value pair from the mapper's output. That is, the file name and the PDF writable object as input. The function of the write is to write the PDF document into HDFS using the file name that we got from the mapper, appending .pdf extension to the file. Now all we have to do is get the reader object from the PDF writable, which we already set in the read files method in PDF writable. The PDF reader is already pointing to a PDF document in the PDF writable. All we have to do is create a copy of the document. So we'll get one page at a time using the reader and using the PDF copy object from the iText library, and add each PDF page to the PDF document and close the document. That is it. Our PDF document will now be returned to HDFS. That is it for the PDF output format. It's very simple and its core essence is the write method inside PDF record writer. Now that we have all the needed programs ready, it is now time to run the program. To run the program, we need a driver program. So let's look at the driver program. The driver program is called text-to-pdf.java, and it's very simple. We set the mapper, input and output format, provide the input and output location. That is it. Let's now build the project using Maven. This project is Mavenized, which means we have defined all the dependencies in pom.xml. So let's look at the pom.xml file. There you go. Here we have listed all the dependencies. More importantly, we have also listed the itext library which we'll be using to read and write PDF documents. Building a Mavenized project is very simple. Simply right-click and just say run as Maven build. If you're running a Maven project for the very first time, it will give you a pop-up box. Simply enter clean space install and hit enter and it will start building. There you go, the project is now being compiled and it's creating a jar file for us. The build is successful and it has already created the jar file. Now I have already copied this jar file into our cluster. So let's go log into our cluster and execute this MapReduce program. The jar for this MapReduce program is copied into HIRW workshop MapReduce text to PDF folder. So here we have the jar file and also we have a lib folder under that directory which has the itext jar. And this is the jar used to read and write PDF files. Alright, the input files are already copied to HDFS in this location right here, input text to PDF directory. So now I'm going to delete the output directory first. The output directory is now deleted. Now let's look at the Hadoop jar command to execute our MapReduce program. It's very simple. You say Hadoop jar, you give the jar location along with the name of the jar, and you give the fully qualified driver program's name here, followed by -lib jars, and give the location of the itext library. Because our MapReduce jar file here doesn't include the itext library. This itext jar will be copied locally to all the nodes executing our MapReduce program. So this library is readily available to our MapReduce job. And next, you will give the input location followed by the output location. That is it. Let's execute the MapReduce program. The MapReduce program is now running. Let's wait for the execution to complete and then let's review the output. There you go. Our MapReduce program is now complete and it completed successfully. Let's go to the application web UI and review the execution. Here's the job that we executed, text to PDF. So let's click that. Click the history URL. We processed about 54 Java files and a mapper is created for each file. So we see 54 mappers and all completed successfully. And our job is a success. Now let's do a HDFS listing on our output directory. There we go. In our output directory, we see all the files with .pdf extension. Why don't we bring these files locally and open the PDF file just to see how it looks? Okay, so I'm going to use a copy to local command to bring the files down to the local file system. Let me bring these files to my Windows laptop so that we can open the PDF file, okay? So I'm going to use WinSCP to bring the files here. So there you go. We see the PDF files. So I'm selecting all the PDF files, copying it over to my local laptop. The files are being copied now, so let's give a few seconds for the copy to complete. Okay, the files are now copied. So let's go to this location right here and let's check out our PDF files. Here is all our PDF files. So let's open a couple of files just to make sure the file contents looks good. There you go. So this file looks very good, right? Text file converted to PDF. Let's open one more file just to be sure. Perfect. Looks good. This is great. We now have successfully converted text files to PDF files using MapReduce. So to summarize, in this lesson, we looked at and simulated one of the successful real-world use cases from New York Times in Hadoop. We simulated the project by creating custom input format, custom output format, and custom writables all in one project. Finally, using all the custom objects that we created, we successfully converted text files to PDF files using MapReduce. With that, let's wrap this lesson. See you in the next lesson.